Example 6. The sluice gate in this picture controls flow in open channel at section 1 and 2, shown in this picture here. Section 1 and 2. The flow is uniform and the pressure is hydrostatic. So let me write chapter 3. Fluid mechanics. The flow is uniform and the pressure is hydrostatic. Neglecting bottom friction and atmosphere pressure. So neglecting the friction and atmosphere pressure. Atmosphere and friction. Derive a formula for the horizontal force F required to hold gate. So derive a formula for F required to hold gate. Express your final formula in terms of the inlet velocity V1 eliminating V2. Express the final relation of F as a function of V1. This is one of the typical problems in the fluid mechanics. At first, we should use the conservation of mass and conservation of momentum. For the conservation of mass, so conservation of mass at inlet and outlet flow. Our inlet has an area of H1 multiplied to B. B is perpendicular to the paper in this example. So m dot equals to rho 1. Rho is equals for both because there is a one fluid. Rho VA, rho V1 HB, and also m dot in out equals to rho V2 H2B. So now we can have a relation between V1 and V2 with the expression m dot in equals to m dot out. Rho V1 HB equals to rho V2 H2B. V2 equals to V1 We may use gauge pressure for convenience because a uniform atmosphere pressure causes no force. As shown in previous example, with X position, the right equals to the net horizontal force to the X directed momentum. So we have only momentum equals m dot b minus m dot b out in. In the x direction, we have m dot u1 minus u2 minus sigma m dot u1. This is the force from the fluid on the gate, so this force should be equals to the force of the gate. So we have F equals to F gate sigma Fx, F gate equals to m dot u2 minus u1. We know that we have a relation for m dot. M dot is, let me write again, m dot fx is f gate equals to m dot u2 minus u1. We have an expression for m dot equals to, for example, rho u1 a1, which is h1 h1b, and also m dot rho u2 h2b, rho ba. So we can replace to the formula, we can obtain this relation. At first, F equals to m dot let me start with 1 rho u1 h1 b multiplied to u2 minus rho u1 h1b multiplied to u1. So F equals to rho u1 h1b u2 we have an expression for between the two velocities, which was u2 equals to u1 h1 on h2. With replacing with this equation, rho u1 h1b multiplied to u1 h1 on h2 minus rho u1 h squared h1b equals to, with the expression simplifying expression h1 on h2 minus 4. This is the relation of f in a function of u1. We can also write the f as a function of u2 also. h1b u1 h squared h1 on h2 minus 1. And if we want to have an expression as a outlet velocity, we can replace u1 equals to u2 h1 on h2. This is the relation for force, the force needed to have a stable gate at the example picture.